Bismillahirrahmanirrahim. Assalamu alaikum. Our today's topic is about equilibrium constant. Now let's dive in a topic. Equilibrium constant, reaction quotient, and Gibbs free energy. K is the ratio of the relative amount of products to reactants at equilibrium, while Q is the ratio at any point of time of the reaction. The Q value can be compared to K to determine the direction of the reaction to take place. The spontaneity of the process is related to the free energy change. Delta G gives free energy, K equilibrium constant, and Q reaction quotient are related as follows. If delta G is smaller than 0 and QC is smaller than Kc or Kp at the start of the reaction, the reaction will proceed to form products. Number 2, delta G is equal to 0 and Qc is equal to Kc or Kp at equilibrium and no more changes in the concentration of the mixture. Number 3, delta G is greater than 0 and Qc is greater than Kc or Kp after equilibrium. The reaction will proceed in the direction to form reactants. Before equilibrium, Qc is smaller than Kc. At equilibrium, Qc is equal to Kc, and after equilibrium, Qc is greater than Kc. It is the equilibrium constant versus reaction quotient. Kc is equal to equilibrium constant measured in moles per liter. Kp is equal to equilibrium constant calculated from the partial pressures. Equilibrium constant for predicting the direction of a reaction. The equilibrium constant can be used to predict the direction of the reaction. We need a term reaction quotient Qc expressed in terms of concentrations or Qp in terms of partial pressures, similar to the equilibrium constant except that the conditions are not at equilibrium. For a balanced reaction, A plus B, C plus D. For a balanced reaction, when A mole of A plus B mole of B form C number of moles C plus D number of moles D. Reaction quotient QC or QP is given as QC is equal to active masses of the product over the active masses of the reactant, or QP is equal to partial pressure of the product over the partial pressure of the reactants. Comparison with Kc and the direction of reaction. If Q is equal to Kc, the reaction is in equilibrium where Kc is equal to equilibrium constant. If Q is greater than Kc, Q will tend to decrease so as to become equal to K. As a result, the reaction will proceed in the backward direction. If Q is smaller than Kc, Q will tend to increase so as to become equal to K. As a result, the reaction will proceed in the forward direction. Thank you very much. Allah Hafiz.